Here we go. Okay, so we have learned the following type of graph, which is a histogram and a frequency polygon. Okay, and just to give yourself like a little bit of information here, you do need class boundaries, which would be like, 70.5 to 75.5. You have to always, if they give you the limit, which they will, then you have to put it into boundaries. And your histogram obviously is just a squished bar graph. That's really all it is. Okay, it's just a squished bar graph, and you put your boundaries here. And then what would be the frequency polygon then? What did we do for that one? You take the what? The middles, okay? You have to find the middle of the boundaries, which really happens to be the middle of these bars, okay? But it's really the middle of the boundaries. So you take the midpoints and you put a dot at each of the midpoint, and then you just connect it like it's a line graph. And then for whatever reason, the book kept going like that, but it doesn't matter, okay? So know the difference. These are midpoints. This is bars, like that are squished together. Now, obviously, there's a bunch more other graphs, so I want you to be familiar with them. You may or may not have to draw all of them on tonight's homework. I think there are some pretty easy ones, but let's talk about a bar graph. Now, what's the difference between a bar graph and a histogram? Well, the difference really is these bars are more categories. They're not necessarily numbers. They're more like, what kind of dog do you like? I like a golden retriever and a poodle, and then you would count up how many poodles there are and count up. So it's a category, okay? So bar graphs are for their vertical or horizontal bars for categories. And then you would just count up how many of those categories. What kind of flavor do we like of ice cream? Chocolate, vanilla, strawberry. You put chocolate, vanilla, strawberry, and you make a bar of how many. That's what you used to do in like kindergarten, okay? Then there is what's called a pareto chart. A pareto chart. Pareto chart is also categories. It pretty much, Pareto is a bar graph. The only difference is the following, okay? You must arrange the bars from your highest to the lowest, okay? So if you arrange your bars, so here's your bar graph of chocolate, vanilla, strawberry, and it looks like this, okay? You would pretty much take that bar graph, that same bar graph that you just made, and to make it a Pareto graph, you would arrange it from the highest. So what would come first? Vanilla. And then strawberry, and then chocolate, something like that. So you would range it from the highest to the lowest. So every Pareto graph must be what skewed? Right skewed. So every Pareto graph is right skewed. They're going to ask this on the test. They're going to say, well, which one of the following is a Pareto chart? You just look for the one that's right skewed. Very easy. Okay. Fourth one is a time series graph. Not times, Mrs. Seta, whatever. There we go. Time series. Time series graph. Okay, and this is over a specific amount of time. Over a specific amount of time. So really, it's over, like they would say, from, plot the amount of medals won in the Olympics. So that would be every 4 years. So you, on your x-axis, you would put years. right? Down here you would have years, and then you would plot what they won, and so it would kind of look like a frequency, but you wouldn't have midpoints here, you would have years. So, from 1984 to every 8 years for like a Winter Olympics, we'll say. So, 1984, 1992, and you'd go every so often in terms of years. That's called a time series graph. There's got to be time in it. Make sense? I mean, I like when math makes sense. Makes me happy. All right. 2 more here that you should be familiar with. A pie chart. We're going to do this tomorrow. Sometimes known as a circle graph. Just depends on the book you're using. The pie chart divides the frequency into percentages. Percentages, okay? And again, what you would have is you have a circle. We're actually gonna draw the circle with compasses. We're gonna, break everything down, and then you'd be like, oh, this is 25% of my frequency is located right here in the people who love chocolate category or whatever, okay? Very easy to do. We'll do that tomorrow because they take a little bit of time. You'll do one of them, and then after that, I think that would be it pretty much. All right, and then a dot plot. Anybody remember what a dot plot is from like kindergarten or like 7th grade? Do you remember what a dot plot looks like at all? It's got dots in it. Sporadic? No, good try. That's a scatter plot. So good job. Actually, I'm proud of you for thinking about that one. So here's what a dot plot does. It puts dots above corresponding data values, I should say. So it's something like this. I don't know, let's say your grades, in class were 70 and 80, 90, I don't know, and 100, okay? You would put dots for however many people got 70, one person got a 70, one person got a 75, 2 people got 80, I got 3 people getting 90, one person getting a 95, like that. Have you seen those before? Okay, really what they're doing is they're just drawing a bar graph. That's really what you're doing, except with dots. Because I could just build bars right here, and you could see, the most I got was a 90. The most people got was a 90. So it's just putting dots above corresponding values. It's called a dot plot. Easy breezy. All right. So we are going to do 1, 2, 3 example, and there's another graph that I'm going to do at the end. I just want to show you what you're doing today. You're going to do a bar graph, Pareto, and time series, and then a stem and leaf plot, which you haven't done in a while, I'm sure. So just to show you examples of what I want, so when you see what I do, you do it. That's how this class goes. It makes me happy. It will make you happy. I promise. Because when you don't do what I do, no happy, Miss Aceta. Let's start with the graph. Okay. So we're going to title this one College Spending for First-Year Students. College spending. What do you think college students spend their first year, most of their money on? Surprisingly enough, that's not even in my categories here from the book. Thank you, book. No. Dorm decor. We'll start with the electronics. Yes, that's true, I guess. So they're going to give you this. They're going to say they spend $728 in electronics. Oh. Dorm decor. Obviously, every boy in here is very concerned about his dorm decor for next year. I can tell.
I don't know. My dorm's going to have to be like raw, though. Like,
okay.
You can't have like just a blank plebeian dorm.
That's true. Okay. Clothing, only $141. This is so not true. And shoes, this is way not true, but $72 because they're like.
That's like my whole spending.
You're like, there is no way, Mrs. Seta. Okay. So you are going to draw a bar graph on this. Okay, so it's up to you if you want to make it vertical or horizontal. It doesn't matter to me. But what you would do is you always put your categories wherever you want to make your bars. So if you're going to put your categories here, you would be making horizontal bars. I'm going to make vertical bars because I just like vertical bars. Categories would go here. So, and you can even just, if it's letters like this, E, D, C, and S, that's what I would actually just write, E, D, C, and S. You want to label things, okay, because it's important. Now, how do we determine our scale on this side? Again, this is money. What would be a good scale to go by? Well, first of all, what do we have to go all the way up to? At least 750-ish, maybe. So what do you want to go by? 50s? I might go by hundreds. 100, 200, 300, 400, 500. Yeah, because I knew I'd run out of space. Whoa. 700 and 800. Okay. And then you make a bar for 728. And again, you just be just slightly over 700, make your bar. Now this is different from a histogram because you do not want to connect your bars. We're not doing class boundaries. So dorm decor, you make a space and then you go to 344. And then clothing, 141. And then good old shoes, 72. And there you go. What have we also just done right now?
Pareto.
We've just done a Pareto graph. Because it is right skewed. So it is a bar graph and it is a Pareto graph. So on tonight's homework, if it asks you to draw a bar graph and a Pareto, make just a Pareto, then you've killed two birds with one stone. If you've heard of that phrase before. Right? Well,
Yeah.
killing birds. All right. Let's do a time series and then we'll do a last one.
You have to be pretty talented to do that in real life, you know. Like people can barely kill birds with a shotgun, much less like your hand or a rock. What? Yeah. True.
I'm glad this spoke to you.
Think about
At first I thought you were
the
talking about the graph, like, as soon as I heard all that money, I was like, okay.
Nah,
And then
I was talking about the metaphor.
That's true.
It is a metaphor. I don't know where it came from, but we can find out. Okay, so here's another one that they want you to do a time series graph for this one. This would be the price of advertisement for the Academy Award show. Don't know if you realize that's a expensive one. So here's the year 2010, 2011, 2012, all the way up to 2015. So if you just want to copy, they're going to give you this. Again, you don't have to do all your data research. And they're going to go 1.4, 1.55, 1.61, 1.65, 1.78, and 1.9. And this is the cost, and this is in millions, by the way. In millions of dollars. Didn't know if you knew that the people pay money. I mean, Super Bowl, yes, but really the Academy Award show? Does anybody in here watch that? No, I don't. So again, to do a time series graph, you need time. There's time, okay? This is usually your x-axis, which is the year. Definitely want your year to be along the x-axis. So 2010, 11, 2012. And you could just call it 14, 15. It's up to you, but label this year. Along my y-axis would be the what? The cost, yes. And then always label, money in millions. You would definitely want to know, we're not spending $1.40 for a commercial, for an advertisement. All right, so how are we going to do this? So 1.4, the highest is 1.9. You could make a break in this graph. To make a break in a graph, and the reason why I'm making a break in the graph is because I'm not starting at 0. So if I kind of want to start at 1.4 because I'm looking at this and I'm going 1.4 to 1.9, that would be easy to go up by like 0.1, right? 1.4, 1.5, 1.6, 1.7, 1.8, 1.9. The problem is you didn't start at 0. So you make a little break here and then you go 1.4, 1.5, 1.6, 1.7, 1.8, and 1.9. And then from there, you plot dots. So 1.4, 1.55 is like here, 1.61, 1.65, slightly higher, 2014, 1.78. This is very similar to a scatter plot, which is what my good friend Jonathan said. And then you just connect them. And that would be a time series graph. And then we got one more to do. So if you have your book or if you have your Connect Ed, I do need you to do this with me. And I believe this is one of your homework problems. No, it's not. I'm not that nice. Good job, Sharon. Go to page 92, number 19. 92, number 19. I'll write this down for you. Drew, I think I have to give you, did I give you a Connect Ed account?
Yeah, it's not on there yet.
What? It's not? I got to give that to you in a minute. You just kind of follow along. I'm sure you'll be all right. All right, so page 92, number 19 talks about length of major rivers. Let me go down here for you so you can kind of see it. Length of major rivers. The data shows the length in hundreds of miles of major rivers in South America and Europe. You have to construct a back-to-back stem and leaf plot and compare the distributions, okay? And that's what everything homework tonight will say. Make a box plot, make a time series graph, make a dot plot, make a this. And so that's all you have to do tonight is just make what they're asking you to make. If they ask you for a Pareto chart and a bar graph, do the same thing, like I said before. All right, so we're gonna make a back-to-back stem and leaf plot. And I don't know if you remember stem and leaf plot, but I'm gonna help you out with it. Mostly everybody does once we start drawing these. But this is the length of rivers. And we are gonna start by doing Europe. So here is gonna be my stem. And then these are going to be the leaves of my Europe one. Okay. Now, if you don't remember what a stem is, and a stem and leaf plot, usually you give us a key, and I'm going to show you what I mean by a key. 3/9 equals 39. Have you ever seen that before? And if I had another 9, I would put a 9 after it. And so I would have two number 39s. This is the stem. This is the leaf. But this is the actual data point. 39 is the data point. If I had a number like 102, do you know what your stem would be for 102? 10. What would your leaf be? 2. That would be 102. Do you see that? That would be, your stem would now be a double digit. So when I'm looking at number 19, and we'll start with Europe, okay? So it looks like I have a single digit, double digit. Double digit, double digit. So when I'm trying to determine what my stem and my leaf would be, if the highest amount of digits is 2, then your stem can be you could have a stem of 0 and a stem of 1 and a stem of 2. Does that make sense? Because 5 can be written as 0, 5. Would you agree? Okay. 18 could be written as 1, 8 for the leaf. If I had a 20, I would write like a 22, I'd write 2 as my stem, 2 as my leaf. So it looks like I only have to have 0 as a stem and 1 as a stem. So that's what I'm going to do. And here's another thing. I have a lot of single digits. So I'm actually going to create 2 zeros and 2 ones. You only create 2 if you have a lot of them that can't fit on the line. If you could fit this all on the line, because you probably have smaller handwriting than me, then go ahead. But I can't fit on the line. Now, these numbers, the leaves have to go in order from lowest to highest because we like order, okay? So looking at my length of rivers, what's my lowest number here in Europe? 3. So I have 1, 3, right? How many 4s do I have? 2. So you would go 03, 04, another 4. Do I have 5s? How many?
3.
There's 4? Okay. So 1, 2, 3, 4. You sure?
Yeah.
Yeah,
Okay.
4.
My bad. How many 6s? 1, 2, 3, 4, 5. You're right. Okay. So see, I'm starting to run out of room. 1, 2, 3, 4, 5. So that's why on my next line, I have to do now my 7s. How many 7s? 1. How many 8s? 2. Any 9s? Any 10s? Any 10s? No. Any 11s? Okay, so now do I stay here and put a 1 here? No, I go to this next. This is my stem is 1 for 11, and my leaf would be 1. 12, I see 112. I see a 13, 113, is that right? 14. Do I have a 15 at all? I think 18 is the next one, right? So actually I don't need to, so I can wipe that out for now. So that was the one side, Europe. But this question asks us to do what's called a back-to-back stem and leaf plot. So you're like, well, what does that mean? So here's what's weird. You go like this. I know, if you don't have room, that's okay. And South America would be on this side. And now the stem is backwards. So it's going to be kind of weird. So instead of, this is still your stem, but now your leaves go this way. Okay, so let me show you what I mean. So looking at South America numbers, I do have a 2. Would you agree? Okay, so here's how you do the 2. There. Why did I put it there? Mrs. Seta, that's 20. No, it's not. My stem is 0. My leaf is 2. That's how you make the stem for the back-to-back part. Let's see if I have another number. What's my next lowest number? 10? How many 10s do I have? 1, 2, 3, 4, 5, 6, 7. Yeah, okay, so now where am I going to write 10, everybody? On the left side, but where? Do I put it with the 0?
No, on the 1.
On the 1, because your stem is a 1, and then how many zeros do I write? 7. 1, 2, 3, 4, 5, 6, 7. That's crazy. That means you have 10 South American rivers in, what were we talking about? In hundreds of miles, okay? And then I actually do need another one, so I am for this one anyway, so I'm going to do this. I have an 11. I have a 12. Do I have a 12? I do. So 12, no 13, a 14, 114. How many? I do have 2 15s, right?
Yeah.
Mm-hmm. Anyway, do you see this process now? Do I need to keep going? So if I wanted to write, let's just do one more. If I wanted to write 39 for South America has a 39. What is going to be my stem?
3.
So down here, I'd go to 3. And then where would I put the 9? Here or here? If I put it on this side, that would be the Europe length. So I put the 9 over here, 39. When you read it back to back, it looks like that. I think I actually did not give you a back-to-back one for homework tonight. I think I just gave you one that looks like this on this side.
Why would you go on the left side and make another column on the right? Just over there.
Why would I not make a what? I'm sorry?
Just make another column on the right side.
Because they purposefully asked us to make what's called a back-to-back. And this is called this right here is a back-to-back. So you just need to know how to read a back-to-back. I agree with you. I would have just made 2 separate ones because I think this is more confusing, but it's all in one thing. So that's it. All right, kids. Now, the rest of the 40 minutes, 40, that's a 4 and a 0, is for you to do 2, 4, 7, 8, 17, and 20. You can do this. You can then show it to me for credit. Okay? Because a happy Mrs. Setta is a happy Will. Right, Will?
Facts.
Let me stop my recording.